The history of the bubonic plague is one of humanity's most awful chapters. Its most famous outbreak, the Black Death, devastated Europe during the late Middle Ages and claimed the lives of millions. Thanks to advances in ancient DNA research, scientists have traced the evolution of the plague-causing bacterium Yersinia pestis through prehistoric human remains. Most of that evidence has come from late Neolithic and Bronze Age farming communities, where close contact with rodents and their fleas made transmission more likely. But a fantastic new study has uncovered evidence of a deadly plague outbreak amongst hunter-gatherers by Lake Baikal in Siberia around 5,500 years ago, which shows us that this disease was spreading through communities before the rise of settlements and agriculture. The sharp population decline that occurred during the Neolithic period has never been fully explained. Known as the Neolithic decline, it's likely that there were several different reasons for it, but one idea points towards the plague having been a contributing factor. Ancient DNA studies have uncovered evidence of repeated plague infections spanning multiple generations of Neolithic farming communities, suggesting that the disease may have played a significant role in their decline. This paper here is particularly interesting, and I did a video on it when it came out. Most ancient plague genomes recovered so far date to between 4,700 and 2,400 years ago, covering the late Neolithic and Bronze Age. These genomes fall into two main lineages, distinguished by whether they carry a gene that produces the Yersinia murine toxin. This toxin allows the bacterium to survive inside the digestive tract of fleas, making flea-borne transmission between rodents and humans much more efficient. In other words, it was a key evolutionary adaptation that helped transform the plague into the devastating disease we know from later history. For decades, the Baikal Archaeology Project has been investigating the region around Lake Baikal in southeastern Siberia, uncovering what life was like for hunter-gatherer communities there during the Middle Holocene. In a new study published in Nature, researchers analyzed ancient human and pathogen DNA recovered from 4 cemetery sites in the Cis-Baikal region, west and north of the lake. These sites all sit on the banks of the river Angara, which drains from Lake Baikal. The burials span 2 separate plague outbreaks. In total, the team examined the remains of 46 individuals and detected Yersinia pestis DNA in 18 of them. These findings show that plague struck communities across all 4 cemeteries in at least 2 major outbreaks separated by several centuries. The cemeteries also reveal distinct burial traditions. At Ust Ida I and Shumalika, people followed the Isakova mortuary tradition, laying the dead parallel to nearby rivers and burying them with grave goods such as mitre-shaped clay vessels, stone arrowheads, and bone or antler points. Meanwhile, the cemeteries of Bratsky Kamen and Serovo belonged to the Serovo tradition, where individuals were buried perpendicular to the river and accompanied by bifacial flint tools and characteristic egg-shaped pottery. These cultural differences suggest that separate hunter-gatherer groups, each with their own customs, were affected by the same awful disease. The highest number of plague detections were found at the Ust Ida I cemetery, which is also the largest mortuary site belonging to the Isakovo tradition in the Cis-Baikal region. The researchers also detected another disease-causing bacterium, Brucella, the pathogen responsible for brucellosis, in one individual from a single cemetery. Although archaeologists in Siberia refer to this period as the late Neolithic, farming and herding had not yet reached the region. Instead, the term is based on technological advances, including the adoption of the bow and arrow, the use of pottery, and new stone grinding techniques. All 4 cemeteries were used over a long period from the early Neolithic through to the early Bronze Age. However, this study focused exclusively on the late Neolithic burials where evidence of plague was found. By comparing the ancient bacterial DNA with other research, the team confirmed previous evidence that Yersinia pestis evolved from its close relative Yersinia pseudotuberculosis, with the 2 likely diverging sometime in the last 50,000 years. The team team also identified small genetic differences between the plague strains recovered from different cemeteries. Rather than a single outbreak spreading continuously through the region, these differences suggest the disease entered human populations on multiple occasions from the same local animal reservoir, most likely wild marmots. In other words, plague appears to have spilled over from animals into people several separate times, with the bacterium continuing to evolve between each event. Although the cemeteries were spread across a vast area, with the most distant sites lying around 350 kilometers apart, the researchers found evidence that some of the people buried there shared recent ancestors. Given that the region is connected by major river systems, which would have acted as natural travel routes, this suggests these hunter-gatherer communities remained in regular contact. Genetic analysis also revealed very low levels of inbreeding and a relatively large population size, indicating that people frequently moved between groups and found partners outside of their own communities. By reconstructing family trees at the Ust-Ida 1 cemetery, the researchers uncovered evidence for a sudden mortality event that unfolded within a single generation. Brothers and sisters of different ages died within a relatively short period, and many children never lived long enough to reach the ages attained by their parents. The cemetery also contains several graves where multiple family members were buried together, further pointing to a catastrophic outbreak. In one grave, 2 siblings were buried side by side, yet only one tested positive for Yersinia pestis. The researchers suggest this may reflect the limitations of ancient DNA preservation rather than the absence of infection, since degraded DNA can sometimes produce false negatives. The mortality patterns are particularly striking. Children are overrepresented in the plague-affected cemeteries of Ust-Ida 1 and Bratski Kamen, suggesting that younger individuals were especially vulnerable. One possible explanation is that adults had already survived earlier outbreaks and developed some level of immunity, whilst children were encountering the disease for the first time. If that's the case, plague may have circulated through these communities far more frequently than the archaeological record alone can reveal. Another possibility is simply that children were biologically more susceptible to severe infection. Today, the natural reservoir for plague around Lake Baikal is the marmot, a large ground squirrel. Hunting these animals for meat or fur has historically resulted in human infections. Archaeologists have even discovered marmot teeth placed as grave goods in earlier Neolithic burials, showing that these animals were hunted thousands of years ago. Although marmot remains are absent from the late Neolithic graves examined in this study, the researchers believe contact with infected wild marmots was still the most likely source of the outbreaks. Depending on how transmission occurred, handling infected animals could have caused bubonic or pneumonic plague, whilst eating raw or undercooked infected meat may have led to a deadly bloodstream infection. Interestingly, the Lake Baikal plague strains represent an early evolutionary stage of Yersinia pestis. They were capable of causing fatal disease, but they lacked the key genes needed for flea-borne transmission, meaning they spread differently from the bubonic plague that devastated Europe thousands of years later. The gene that produces the murine toxin was absent. Although these early plague strains couldn't cause classic bubonic plague, they carried a potent toxin that may have triggered dangerous immune overreactions, especially in children, making them highly lethal in a very different way. The study fundamentally changes what we know about the origins of plague. Rather than emerging amongst early farming communities, the earliest known plague outbreaks now appear to have struck hunter-gatherers in Siberia more than 5,500 years ago. This supports the idea that plague first evolved in Central or Northeast Asia before spreading elsewhere. Prior to this research, the earliest samples had been found in Northern Europe. The evidence also suggests these were genuinely deadly outbreaks. By combining ancient DNA with radiocarbon dating, burial patterns, and family relationships, the researchers found that many people died within short periods of time. Together, these findings provide the strongest evidence yet that plague was already causing fatal epidemics thousands of years before the rise of the settlements most commonly associated with the disease. If you're interested in the plague, And who isn't? Some great papers have come out over the past few years. This study, published in 2021, reconstructed the Yersinia pestis genome from a single hunter-gatherer buried in a shell midden in Latvia. The strain it belonged to was an early divergence from Yersinia pseudotuberculosis and didn't have the gene for effective flea-borne transmission, so it's not clear how badly this hunter-gatherer was affected by the infection. Obviously, this study couldn't prove a widespread prehistoric plague pandemic. It could just be an example of an isolated zoonotic spillover, but it's interesting in that it's also a very early case of plague infection. Another study, published in 2025, analysed the Yersinia pestis genome extracted from a Bronze Age sheep in the Eurasian steppe. This paper revealed that Yersinia pestis likely spread more widely and frequently during prehistory than previously thought, possibly involving multiple animal hosts, including livestock. Ancient DNA shows repeated spillover events from a wildlife reservoir, which shows there was a complex transmission cycle, and this suggests that the plague was already established in prehistoric ecosystems. I've listed these papers in the description below. They are open access. Let me know what you think about the history of the plague in the comments. Thank you for watching, as always, and I'll see you next time.